We are going to evaluate trig ratios in special triangles. This is coming from topic 7.1, example 4. So you might remember from geometry, we have special right triangles. We have a 45, 45, 90-degree triangle and a 30, 60, 90-degree right triangle, and they have special characteristics. We've got ratios that are always constant. So if we look here at this 45, 45, 90 triangle. Remember, this is isosceles. If your angles are congruent, that means your legs are also congruent. So this side is going to be congruent to this side. Now, our measurement, we're just going to call it x. They're the same. And the hypotenuse is going to be whatever those leg measurements are times the square root of 2. If we look at a 30, 60, 90-degree triangle, remember your shorter leg is always opposite the smallest angle. So my smallest angle here is 30 degrees. So my short leg is opposite that. And your short leg is just some distance, we'll call it x, some length. Your hypotenuse, the hypotenuse here is always 2 times the distance or the length of whatever your short leg is. So this is 2x. And then your long leg is going to be your short leg times the square root of 3. Now let's use that knowledge to go ahead and take a look at these two triangles, and we're going to write out our 6 trig ratios. So on A, you can see this is going to be a 45, 45, 90 triangle. And again, on those, I know my legs are congruent. So if this leg is 2, this leg also has to be 2. And my hypotenuse is always that leg times the square root of 2. So now let's go ahead and write our 6 trig ratios. We have the sine of theta equals opposite. So here's my 45, 2 over the hypotenuse, 2 over the square root of 2. 2 over 2 times the square root of 2, excuse me. Now notice here this can reduce, but now I have a radical in the denominator. We cannot have that. So that means I have to rationalize the denominator, and I get square root 2 over 2. Let's go ahead and do the reciprocal. Let's see if we can squeeze this in. I didn't leave a lot of room. The reciprocal of sine of theta is cosecant of theta, which means we would just have to flip the fraction. But if I flip the fraction, notice how I'd end up with a radical in the denominator again. I'd have to rationalize that denominator. But if I come back over here, look at this, where I reduced already 1 over the square root of 2, I can go ahead and flip this, and the reciprocal is the square root of 2. And now let's do cosine. Cosine is adjacent over hypotenuse. Okay, so here is my theta. Here's adjacent 2 over the square root of 2. Well, it's the same thing as sine. And I'm not going to bother redoing all this. We know it. So there we are. Cosine of theta, cosine of 45 degrees is a square root 2 over 2. The reciprocal of cosine is secant. And again, it's going to be the same, square root of 2. Just got to flip that fraction, and again, get it from right up here. We're not going to do double work. And now let's look at tangent. So now the tangent of theta is opposite over adjacent. So opposite over adjacent. So that is 2 over 2. And if we look at the reciprocal, cotangent of theta, well, if I flip that fraction, I still get 1. Let's take a look at B. Triangle JKL. I've got my 30 degrees here, which means this would have to be 60 degrees, 90 degrees, 30, 60, 90 degree triangle. And 30 degrees, this is going to be my short leg. So, and again, this is the short leg. Hypotenuse is 2 times that length. 2 times 4 is 8, which means this is the long leg. The long leg is going to be the short leg times the square root of 3. So this is 4 times the square root of 3. And now let's go ahead and calculate those ratios. Sine of theta, so we're actually calculating the sine of 30 degrees, was opposite over hypotenuse. Opposite hypotenuse. 4 over 8 is 1/2. Let's go ahead and do the reciprocal right away. Reciprocal is cosecant. And if you flip your fraction, you get 2. Cosine is adjacent over hypotenuse. So here's my 30 degrees. Adjacent is 4 times the square root of 3 all over the hypotenuse of 8. Let's reduce 4/8. 4/8 is 1/2. Square root of 3 over 2. And now the reciprocal, secant. Okay, this one I'm going to have to flip 2 over the square root of 3. Rationalize the denominator, so I'm going to multiply top and bottom by the square root of 3. And I get 2 times the square root of 3 all over 3. And now tangent. Opposite over adjacent. So here is opposite over adjacent. So that is 4 over 4 times the square root of 3. I can reduce this fraction. 1 over the square root of 3. We need to rationalize that denominator. And I get the square root of 3 all over 3. If I write the cotangent of theta, and again, I would just grab it right here. This is equivalent for if I just flip this, my 4's would still cancel. I get the square root of 3.